Good morning, this is Miss Billerbeck, and we're going to talk about 1.5, scientific notation. So a number expressed in the form of a times 10 to the n, where a is between 1, so it's less than or equal to 1, and it's less than 10. So it can't be 10, but it can be 1, all right? And n is an integer. So it's called the scientific notation of a number. Okay, so the scientific notation of a number. That's what we're going to be learning today. So let's express the following numbers in scientific notation. So if we have 378,000, we want to move this into scientific notation. So if we put a decimal here, we count, we're moving 1, 2, 3, 4, 5 places. So if we were to write this, we'd write 3.78. And to move that decimal, I had to move it 5 places. So each place is multiplying it by 10. So I moved it. So if this would be 3.78, each time I multiplied by 10, I moved that number, that decimal, over 1 place. So if we move backwards to see how many decimal places we moved from this place, 1, 2, 3, 4, 5 tens. So we multiplied this number by 10 5 different times to make this number. All right, to make this number, we had to go the opposite direction. We had to divide by 10. Okay, when we divide by 10, we're talking about negative exponents. Remember, because 10 to the negative 1 is the same thing as 1 over 10. So that's the same thing as 1 divided by 10. Okay? So when we have something small like this, we're dividing by 10. So let's look at how many times we're dividing by 10. So if we move 1, 2, 3, 4, 5. So to make this into scientific notation, we'd write 9.2 times 10 to the negative 5, because we had to, in order to make this number, we had to multiply it by 10 times. 1, 2, 3, 4, 5. Okay, so if we look at it the reverse direction, we had to multiply this number by 10 5 times to get this scientific notation between 1 and 10. So this number is between 1 and 10 and less than 10. It can be 1, but it has to be less than 10. So let's express each of the following as an integer or decimal. So in this case, we see we're multiplying by 10 4 different times. So if we write this number out, 7, 9, 2, and let's add a few zeros because we're not quite sure how many we're going to need. Okay, but the decimals here, so remember we're multiplying 10 different times, or 4 different times by 10. So we're taking this decimal, we multiply by 10 once, twice, 3 times, 4 times. So the decimal relocates here, and we can change this to that. And we really don't need to put a decimal right there, but that tells us the end of the number. All right, so this one means that we have divided by 10 this many times. So we're going to put a lot of numbers here. And then we're going to write 2, 6, 8. Okay, so this means we're going to move 5 places from here. So 1, 2, 3, 4, and 5. So our new decimal goes here. And we're going to erase that. Okay, so this would be the expansion of this. Whenever you see a negative exponent with a 10, it's a very, very small number. And whenever you see a positive exponent on a 10, it's a very big number. All right, so let's look at a couple study aids that I have. And let me pull those up and share them with you. All right, so let me go back to my meeting and all right, so let me share my screen. And for a moment, you're going to see what I see on my screen. Everything is backwards. Okay, so let's go to this. All right, so this is an example of how we call the factors of 10, the names of the factors of 10. So here's the name. So of course we have 1, this is 10, 100, 1,000, we have 1,000,000, billion, trillion. Look at those. So I have trillion, we have 1, 2, 3, 4 different groups of 3 zeros. So a million, we had 6 zeros, which is 2 groups of 3. So 10 to the 6th is a million. A billion's 10 to the 9th. A trillion's 10 to the 12th. A quadrillion is 10 to the 15th, and a quintillion is 10 to the 18th. Okay, and then these are some of the prefixes that you might see. Mega is pretty common. Kilo is common. Hecto, deca, you've seen those. Giga, gigabytes, 10 to the 9th. Terabytes, 10 to the 12th. Okay, so then when we go down here, we have 1/10 is 10 to the negative 1. 1/100th, 10 to the negative 2. So deci, centi. 1,000th, 10 to the negative 3 is milli. 1,000,000th, 10 to the negative 6 is a micro. And 1,000,000,000th, 10 to the 9th is a nano. We were dealing with this in the 80s as far as our dimensions on chips. And then we went down to a pico. which is 1/100000th, 10 to the negative 12th, and that was really amazing. We did that with light. We cut silicon with light at that time instead of chemicals. And then you have a quadrillionth and a quintillionth. Look at all that. Okay, so let's look at, well, what does all this mean? Okay, so when we look at things like bacteria, we see things that are very small. So we have, so here we have atoms is 1 nanometer, and molecules are 0.1 nanometers is an atom, but a molecule is 1. And then we have micros, macromolecules, viruses, 100 nanometers, bacterias. Let's look at the name for that one. Okay, so we see the mu. So the mu is micro, so 10 to the 6th. And nano, we were dealing with 10 to the negative 9th. Okay, so let's look at that. Okay, so 10 to the negative 6. And then we get into blood cells. So the bacteria is 1/10 of a blood cell. Okay, and then eukaryotic cells. You'll probably be learning that soon. 100. Let's look at that again. So I say it correctly. 100 micro meters, and then a human egg is 1 millimeter. Okay. So I think I have another one that I did not grab. So let me grab that one really quickly. I thought I grabbed this one and I didn't grab it. Okay, so this one, we have 1 meter is about the size of a foot. Okay, and then we have tapeworms, yikes, and all these things. So this gives you another perspective. Fungi and yeast are around this area as far as this is all in scientific, more in scientific notation because it's 1 times 10 to the 0. And you have amoeba, you have bacteria. Okay, so then your viruses are way down here. You have all these viruses. So, and then bacteria are right around here. All right, so that gives you a perspective of why you need to know scientific notation, especially on the small end. When we deal with stars, we need the positive exponents to talk about distance and light speed and all that from Earth to Venus to Jupiter to Andromeda. Okay, so we need to compare magnitudes, which is what scientific notation does. Okay, so let's go back to where we were. Okay, so let's look at the computation. So if I'm adding this, well, one thing I see, I have different magnitudes right here, so I need to get this in the same magnitude. So let's do that. So if I have 4 times 0.7 times 10 to the 7th, and I want that in 10 to the 6th, I'm just going to multiply, take one of these 10s. So if I have 4.7 times 10 to the 7th, and I want to get that the same as this, I'm going to take this and I'm going to take one of those 10s here away from this 10 to the 7th, because I know that 1 plus 6 is 7. Okay, but 10 times 4.7 is 47. So now, so this part is 47, and then I have times 10 to the 6th. So now I can add this together. So I have 47.0, and then it's 10 to the 6 here. So I'm adding the same magnitude together now. So when I add this up, I have 9, and then 10 times 10 to the 6. But wait a second, that's not scientific notation. So now I have to step one back, and I need to take 50, and I need to divide it by 10. So if I take 50 and divide by 10, that means I also have to multiply by 10 somewhere, because I can't just go and divide something by a number without multiplying. So let's look at what I'm actually doing here. So I'm actually going to have to multiply by 10 over 10 to get rid of, to move this decimal to the right spot, because it's not in scientific notation. So I'll erase this to have some more room. So if I divide this 10, so I'm going to rearrange it up here because I need some more room. So if I take this and I divide by 10, and then I take that and I let it be a 10 to the 1 at times 10 to the 6. Okay, now this is decimal is going to get moved over to 5.09. And then I add these exponents together. 1 plus 6 is 7. And I have 10 to the 7th. Okay. Now, probably it would have been more simple if I had moved this one over in the beginning. So let's take a look at that, because this was a little bit convoluted since I moved it this one over, and then I had to move it back. So let's see if it would have been more efficient if I had moved the smaller one when I'm adding. And then I would have had the answer right at first. Okay, so let's remember that's the answer. So let's do this the opposite direction. Okay, so if I decide I want to set this up where this one's moved, so this one I'm going to multiply by 10 over 10, because I want to get this one to 10 to the 7th, because I know that this is the answer, so there must have been a better way. That was too much work. Okay, so we have 3.9 times 10 to the 6th. All right, so if I add that 10 to this, I end up getting, so that's a 10 to the 1st plus 10 to the 6th, so I end up getting a 10 to the 7th. But then I'm dividing this one by 10, which moves the decimal place over one spot. So I end up with 0.39. Okay, so that gives me 10 to the 7th. And then when I add these two together, I have 9, 10, carry the 1, and 5. So I end up with the same thing that I have here, but that was much faster. Okay, so we might want to go with, if we're adding, this is the bigger 10, just move over the smaller one, because it just saved a bunch of steps, don't you think? Okay, so part of doing math is being strategic and trying to limit some of the work. Okay, so this one we're subtracting. So let's get a feel for how we're going to do that. Okay, so this is bigger than that. So that's a good thing. We're subtracting something smaller, but we should have the same magnitude, and we don't. So let's multiply this one by 10 over 10, because we have to add 110 to negative 14 to make it negative 13. Okay, what that does is we're going to divide this one by 10 if we're going to add this one to that. So this ends up 0.61601 times 10 to the negative 13. Okay, because negative 14 plus 1 is negative 13, and I'm dividing 6.01 by 10, which just moves the decimal one spot. Once I have it like this, I can subtract. So I put it over here, 601 times 10 to the negative 13. So now it's the same magnitude and we can subtract. So I'm going to need a little zero right there. Let me put a zero right in here. All right, so what I have to do is take one from here and make that a 4 and carry 1. So 10 minus 1 is 9. 4 minus 0 is 4. I need to carry 1 from here. 12 minus 6 is 6. And then I have 7. And then that would just be 10 to the negative 13. So that would be my final answer. Okay. Oops. Now, when we're multiplying, it's slightly different. We don't have to worry about magnitudes until the very end. Or we don't have to worry about magnitudes. We can just multiply them together. So first, we're going to multiply 9.5 times 4, and then we're going to deal with the 10 to the 13th and the 10 to the negative 6. Okay, so let's use the dry erase calculator here and find out what 9.5 times 10 to the 4 is. 4 times 5 is 20. Carry 2. 4 times 9 is 36, plus 2 is 38. And the decimal goes right there. So this is just 38. So we have 38. And then if we use our exponent rules, it's just 10 plus 13 plus a negative 6 right here. Okay, so 13 plus negative 6 is 7, because it's the same as 13 minus 6. So we have 38 times 10 to the 7. All right, this is not scientific notation because 38 is greater than 10. So we have to find a way to move the decimal over 1. So that means we have to divide this by 10. So we have to multiply by 10 over 10 because we're going to divide that by 10. So, and then we're going to add a 1 right here. So when we divide this by 10, we get 3.8. So that one's all taken care of, times, and then 7 plus 1, so it'd be 10 to the 8. And that would be our final answer. All right, on this one we're dividing. Okay, so Remember I said division was a lot like this, where you have 2.38 times 10 to the negative 5, and you put that over 1.4 times 10 to the 4. That kind of shows us what we're going to do with the tens, but we have to divide these two. So let's use the dry erase calculator. So top dog goes in the house. So we have 2.38 and 1.4 here. We're going to move the decimal over here, so on. Okay, so there's 114 and 23. And we subtract. And 13 minus 4 is 9. We drop this down 8. Let's hope for an even number here. So, well, we could say how many 15s and 90. 15s and 90, so there's 2 and 30, there's 3, so there's 6. So let's say 7. Let's guess 7. 7 times 4 is 8. Carry a 2. 7 times 1 is 7, plus 2 is 98, and we have a 0. So this ends up 1.78, or 1.7, which is a good scientific notation number. It's between, it's 1 or less than 10, so that one is fine. But now we need to figure out our tens. All right, I'm going to erase this. And we have 10, and we're going to have negative 5 minus 4. So negative 5 minus 4, which is 1.7 times 10. And we have 2 negatives, so we're $5 in debt, and we spend $4 more, so 10 to the negative 9. And this is perfect scientific notation, so we're good. All right, last example of scientific notation. Okay, so the storage capacity of a memory card in a digital camera is 16 gigabytes. Okay, so let's look at gigabytes again. So gigabytes are 10 to the 9th. So we have 16 times 10 to the 9th are gigabytes. Okay, and suppose each digital photo takes up 4 megabytes. Okay, so we're talking about 4 megabytes. How many can be stored? So we're going to have to divide, and it's 4 times 10 to the 6. It's 10 to the 6 is megabytes. And now we're talking about bytes. Okay, so again, 16 times 10 to the 9th, and we can divide by 4 times 10 to the 6th. And 16 divided by 4 is just 4. That is between, it's 1 or less than 10, so that is fine just the way it is. And then we're going to do 10 times 10 to the 9 minus 6. So we have 4 times 10 to the 3rd photos. Okay, can be stored. Do you know how many photos that is? Well, 10 to the 3rd is 1,000, so that means 4,000 photos can be stored on a memory card that's 16 gigabytes. Okay, so that's kind of cool. 4,000 photos, that's a lot of photos. I took about 300 photos when I went to Africa. So that's a lot of photos, 4,000 photos. All right. So that's it for this section 1.5 on scientific notation. I hope you have a wonderful day. Bye-bye.